Hello, welcome to Mechan 2040 Solid Mechanics. I am Globus. In this tutorial, I'm going to introduce you stress and strain and their concepts. So the agenda today includes 1.1 direct stress, strain and deformation, 1.2 shear stress and shear strain, 1.3 I will introduce you some examples about shear and shear strain. Also, I will introduce you what is the Poisson's ratio and what is the relationship between the Young's modulus and the shear modulus. In 1.5, we are going to study the sign convention of shear forces, while in 1.6, we are going to learn a little bit about stress-strain diagram of materials. So this concept will be introduced in Mechan 2410, Engineering Materials 1. You will do a lab for that. So first, let me introduce you direct stress. So from the secondary school, we've already learned that when we apply a force on a surface, it will generate a stress. So consider this region, and it has a distributed stress. The strength of the stress is shown here. Green means very small strength, while the red color means the strongest strength. So if we take a differential area, which is here, so the differential area is dA and the local stress is P, then the differential force acting on the region will be dF. And similarly, as what we did in tutorial 0, to get the sum of the force, we do the integration of the stress distribution over the entire region to get the total force. But I believe such thing will not be used anywhere, just give you some very simple introduction. And the local stress for the non-evenly distributed stress, like this. So you can see the stress is not evenly distributed. Then you can only say, okay, the stress here is what? The stress there is what? Or you may want to say, okay, the average stress is what? You can say the local stress. That means the stress 1 point on this region, P, will become the limit of the very small area near this point. Differential force divided by the differential area. So those are very basic concepts about stress.